Let's talk briefly about the 3 things that need to be true to make a causal claim, and then you're going to read it again with more detail in your textbook. Let me bring a slide up real quick. All right, share this. Okay. All right, so we only make causal claims when we're running an experiment. But it's nice to think about these things that have to be true to make a causal claim. So for saying the independent variable causes a change in the dependent variable, x causes y, what has to be true? Well, those 2 variables, the IV and the dV, do have to have some kind of covariance, meaning they have to be correlated. If one is causing the other, when the first one changes, the other will also change it. Now, that is also true of correlations, of association claims. They do have covariance. But that's not enough for a causal claim. It's what you would say is necessary but not sufficient. So you have to have it, but you also have to have more to move on to a causal claim. The next thing you have to have is temporal precedence. Temporal means time, precedent before. So the thing that's doing the causing, the IV or X, has to come first, and then that produces the change in Y, which follows. Okay, so the change in the dV follows the application of the IV. Now, some correlations actually have this. Some association claims you're going to measure something, one variable, and then measure something else later, and so there is this time component. A lot of association claims don't have it, but some do. But again, that is necessary to get to a cause and effect claim, but not sufficient. We have to have this last thing. And the last thing is what correlations or association claims lack, and that's the internal validity. We already talked about internal validity as one of our big 4. And again, it's the fact that we've controlled for confounds or controlled for alternative explanations for the change that we saw in our dependent variable. Now, this is what correlations never have, because association claims, correlations, I'm using those interchangeably, you're just going out and measuring variables as they are. And in any correlation, there's always the issue of, well, okay, we see this relationship between the variables, but it could be something outside of it that's driving it, some third variable. And this is what experiments are designed to rule out and to control for. So experiments have this internal validity, and correlations or association claims don't. So that's the big thing. Now, I really want you to pay attention to the examples your book uses in these pages, as particularly in how associations lack internal validity. They lack that control for confounds. Okay, so that's all I wanted to say, just kind of introduce the ideas to you, and now go read those pages in your textbook as assigned, and really pay attention to the detail of the examples they give you. Sorry. And of course, then you can go ahead and complete your quiz and any assignments as directed. Thanks.